Wait, Gavin, you were absent yesterday, right? So, like I said, video is right there to get everything from yesterday's notes. But we're going to talk about some of them and how to do it with using the graphing. So this is the front page from yesterday's notes. So go ahead and get it out so that we can fill this part out together and talk about it. Because on your assignment on Go Formative from yesterday, it asks you, is the question asking you for the vertex, a random point, or the y-intercepts? That's part of the questions on the Go Formative assignment. So if it is asking you for a maximum height, okay, or the time at the maximum height or whatever, that's the vertex point. Depending on if it's asking you time, okay, if it's asking you for time, it's wanting the y-coordinate. If it's asking you for the height, it's wanting the, if it's asking you for the time, it wants the x-coordinate. If it's asking you for the height, it wants the y-coordinate. If it asks you for, what's the time when it reaches so high, or how high it is it at this time, that's just a random point on the graph. It would just want you to read the graph and figure out where it's at in its trajectory at that time. When it asks about it hitting the ground, okay, it's talking about the x-intercepts. Except for we don't care about this one where it started at most of the time. And most of the time it wants to know how long it takes until it hits the ground, not how long it takes until it starts, because that question doesn't even, it says 0, right? When it starts. So if it is asking you how long or how much time until it hits the ground, right? It's talking about after it was already hit, not when it first started, right? That's a common sense question. So what are the other ways that it could ask that question? What's the other terms that could be used if it's talking about the x-intercept?
The zeros.
The zeros.
Solutions.
And
root.
And roots. These are all the exact same thing, guys. You need to know that if it asks you for any of those 4 things, it's talking about the same thing. Always. That needs to be ingrained into your brain, vocabulary words wise. So the foldable that I gave you today, this is the front page there. Quadratic real-world problems can also be area models, not trajectory or height problems or whatever. They can also be area problems, because if I have a rectangle and I have a side length of 4x minus 2 and another side length of x plus 5, if I have to figure out the area of that, okay, now let's make that not look like a 14. So 4x minus 2 times x plus 5. That would be a quadratic equation, because when I multiplied those together, it would give me a quadratic problem. Okay, it would give me something with x squared, which makes it quadratic. So in that case, when you see it on a graph, it's not how that it's going through the air, okay? But it is talking about the possible side lengths, or the biggest side length or the smallest side length. Okay, so your X and your Y's are talking about the side lengths of the rectangle that's going to be created. So it's a little bit harder to see that an area model is still a quadratic. But the vertex is still going to be the maximum, okay? The maximum side length for one side and the maximum side length for the other to get the most, or to get your the most area. You can also, can you have a side length of 0? Still get a rectangle?
No.
No, right? That is why that the data starts up here. Because that's the beginning possible side length for you to actually still have a rectangle. Because you can't have a side length of 0 or just be a line.
That rectangle?
You don't have to. It was just an explanation of why that an area model falls under quadratic. Yeah. So on the inside of that foldable, this page is what should have been in there, but I accidentally copied the same page twice, and so you have the area one again. So tomorrow I will have a copy of this for you to tape over that one because I printed it wrong. Okay. But this is going to tell you the same information that this last page tells you, essentially. Okay. This is an actual word problem that is showing you how it works. Notice over here, domain and range. These are still getting mixed up. On all of those warm-up problems that we had, okay, I still have people mixing up domain and range. Which comes first alphabetically?
Domain.
Domain comes first. Which comes first in your X and your Y? X. So those two go together. Okay, the domain and the X. They come first alphabetically. They come first together. Well, he went to the restroom. Anyway. Okay, so range and Y. When you are dealing with real world problems, okay, you cannot have negative time and you cannot have negative distance. Therefore, they're always going to start at 0. Okay? That's always going to be your lower boundary. Even if on your graph that you graph on Desmos or on the calculator goes past 0, it doesn't know that it's a word problem. You have to know that they can't be any less than 0 because it doesn't make sense in real world problems. For the domain, your solution or your last x-intercept, okay, is going to be your ending amount. Okay, for the range, your vertex is a boundary. Now, one of our examples that we're going to talk about today is going to kind of be backwards, so you can see how that you could start with something different than the snare, but most of the time this is how it's going to be. At the bottom of this page is telling you how to use your graphing calculator to get the information that you need on the calculator after you graph it. remember that you can hit Control T to get the table of data. So we're going to practice doing this. So again, if you didn't grab a calculator today, you need to go get one so that you have it for what we're going to do. Okay, now to the assignment, or not the assignment, to the full page notes that you picked up, because there was nothing to fill out on that folded one. That was just information for you. So now, look at this other page. Abraham, get up for me. Look at this other page. Let's get through this quickly, and then you have time at the end of class to work on stuff. What do you notice different about this one than all of the ones that we've talked about so far?
That one side is longer than the other.
Okay. One side's longer than the other.
That point starts on the right intercept.
Okay. So on all the other ones that we've done, we've talked about trajectory, like something going in the air, right?
Yeah.
Right. You hit in the ones yesterday. You hit a golf ball in the air, a baseball in the air. You kicked a soccer ball in the air. On the ones up above was a rocket going into the air, right? So all of them started from somewhere low and went up, and then went down because of gravity, right? So this one is different because what happened? It's going down, right? It's upside down. It's making a valley instead of a mountain, right? Does it make sense? What's the word problem talking about?
A diver. Height and feet.
A diver jumping off the diving board. So does it make sense that when this diver jumps off the diving board,
it was 10 feet in the air, and then it went down to the water, and that's what brought him in the negative.
So what would the x-intercept, or what was the x-axis represent?
The top of the
water. The top of the water. Okay. So in a case like this, does it make sense to have some negative distance? Yes, because it's not the ground where he's going to go splat, right? It's water, so he's going to be able to go underneath the surface of the water and still come back up.
Like, say if he was jumping off his house to a trampoline, they'd go like,
okay, yeah. Okay, so when we're talking about trajectory of things, the graph makes more sense because it's like what the motion looks like. Okay? When you're dealing with area, it's a little bit harder to kind of see the correlation, but when you're talking about how stuff is going to fall, it makes more sense. So now, if we read our questions down below, okay, how long does it take the diver to reach the water?
10 seconds.
To reach it? The first time?
Oh, no.
it takes him 3.
About 3 seconds, right?
3?
Yeah.
To reach it right here, when he dives off the diving board, right? And he's going to hit the water right here. So it takes 3 seconds. Are you writing this down, Gavin? Or are you sleeping? Come on. Abraham, you writing it down?
Yeah.
Okay. So, how long does it take the diver to resurface?
6 seconds, or 10 seconds.
No, you're right first. Why? Well, not 6,
Or no,
but 7 seconds, right?
Because he's holding his breath. He's such a gangster.
Okay, because it starts at 3 and goes to 10 that he's underwater. So the phrase resurface means here it went under and then he comes back up. So to resurface, it takes 7 seconds. Okay. How deep does the diver dive? Okay, now hang on a second. Do we use a negative number to describe distance? No. So even though it's at -4, because the way the question is worded and it's a real world problem, what number are we going to actually say?
We would say, no, we would say,
Gavin, right now.
wait.
No, we would say 4 feet deep or just 4 feet. even though it's
Oh,
negative.
Okay, but see, you would have hit his head if he really jumped from there, you know? You know what I'm saying? So it's -4 or 4 feet down?
Just 4 feet. We don't use the negative because it's a real world problem.
Yeah. Oh, okay, that makes sense.
So how long does it take for the diver to reach his deepest point?
4 seconds, or, yeah, no. So,
About 6 seconds.
7 seconds.
6 seconds.
6.5.
4 seconds.
6.5.
6, I got close.
Okay. Because the vertex, and if you're not sure what that number is, you can always graph it in your own calculator and get it. But it's not at 7 because it's already curving back up at 7.
Right.
And it's not 6, so it has to be somewhere in between. Right? What is the domain and range of this function? So this is that one where I was telling you.
Okay, right. The domain is x, which would be 10 seconds, and then the wait.
Okay, it has to include all of the possible x values. So what's the starting time?
Maybe 3.
All real numbers.
No. If it were not a real problem, if it was not a real world problem, then
3,
yes, all real numbers.
3, 2, what? 3, 6, 10.
25.
3, 6, 10. 3, 6, 10.
So does the diver disappear in the air and you don't see him again from when he dives off the diving board and he goes invisible until 3 seconds, and then he's there again and he goes invisible until 6 seconds, and then okay, so you can't just pick out random points to put as your domain because he's in the air the whole time from when he started at 0 to when he resurfaced. So his whole motion is from 0 to 10. You have to include the whole time. You can't just have the random points. Does that make sense? That's why we write it like this, because it includes everything from when he jumped off the diving board until he resurfaced. Okay?
Right.
So now, if we're talking about the range, what would you say the range is? Nope. Again, it's a real world problem. So nothing's going to be all real numbers in a real world problem, guys.
So it'd be 0 to 10.
No, it would be 10, right?
0. Yep. Why is it at 0?
Because it's
Well, actually, is this one at 0?
Yeah, because he's climbing the ladder. So
Nope.
he started off.
So he's 10 feet in the air already?
Nope. Where's my lowest point?
1.
-4.
-4.
I thought you said we could have negatives.
This is why this is an example problem. So I can show you one that a negative would make sense because he does go underneath the surface, right? So a negative for this one does make sense because the lowest he goes is 4 feet underneath the surface of the water, right?
Yeah, sure.
Why? And less than or equal to, what was his top height? 10 feet above the surface of the water. Okay. So when you're talking about it like this, Jonathan, where that you're given the actual range as an inequality, you would use that negative because we're just talking about the number line specifically. Up here, when it's answering the question, we don't, because the way the question is worded, we would not include the negative. Does that make sense? So now, is this one graphed for us?
No.
No, so we're going to have to graph it on our graph. So here's the mistake that happens on here. If I put it in my graph, am I going to use the letter T? If I put it on my calculator, do I use the letter T?
No.
No, what do I use?
X.
X. So when I put it in my calculator, I've got to clear my. come on. Okay. So when you get your graph up, what are you going to type in? Here.
60x
60x
Minus 10x over power.
Square.
I don't even know how I got that on there. Anyway.
Wait, wouldn't that be power to 12?
Okay.
12.
No, power, like 2. You know?
The power of 2 or
I
squared.
said 10. Oh, I did say 12.
Okay. So, does this graph give me all the information I need right here?
No, we need to widen it out.
We need to see my hump, right? Gavin, Cutter, come on. Okay, what do I need to do?
You need to press number 6.
Okay, well, I got to go to menu first, right?
Yeah.
Okay, number 6.
And then
Maximum.
no, the
Maximum.
intersect.
Okay. The intersection?
Yeah.
No, the maximum.
It's the maximum.
The maximum? Okay, here's my, it won't give me my maximum or minimum if I can't see it on here.
Oh.
Okay, I've got to be able to see it first. Yes, you could get your 0, but I need to know what my vertex is. I need to know the top number,
so
right?
dy is dx.
I need to zoom out. I need to use my window so I can zoom and see.
I went to the wrong setting.
Okay, so once that you can see everything, then yes, you would use the analyze graph.
There you go.
But until we can see everything, okay, we need to, boys, do I need to separate you?
Yeah, I'm moving. Yeah, get with that kid. I don't move.
Okay, so you can zoom out. You can try to see if just quadrant 1 would get it. Okay, you could tell it to fit the data. Okay, any of these, okay, if I do it like this, that really gives me all this negative space that I don't need down here, right? So that's probably not my best option. Okay, boys. But if I do it to fit the data and I want to zoom in to this particular space, okay, doing the fit works. But then I'm going to do this zoom box because that's going to allow me to draw a box around the information that I just want to see, and it'll zoom it in like that for me. Okay. Then hit escape, otherwise I'm going to have another box here that I don't want. So this is the arc that I want to see. Okay. Another way you could do this is in Windows Zoom, you can do the settings. Okay, and this is going to let you put exactly what you want to see on the screen. So since it already gave me a graph, I would know what kind of numbers I'm going to be looking at, because the paper version tells me that the highest is going to be less than 100, obviously, and the seconds is going to be less than 10 or up to 10. So if I put my X minimum, and I'm going to still leave a negative number there, but my X maximum I'm going to put as 10, because that's what it shows on my graph, that would be the maximum that I would need to see. Changing your scale right here, okay, to count by 1, because that's what it's counting by on my paper. My Y minimum, again, I still want to include something negative, even though, just so I can see my axes. If you put 0 on here, you won't be able to see your axis. So it's counting by 10s on my y-axis, so I'm going to put negative 10 as my minimum. And for my maximum, what is my maximum on the graph on my paper? 100. Okay. And I'm also going to change the scale to count by the same that it is on the paper. What's it counting by on the paper? 10. So I'm going to change my y's to count by 10s on my graph too. Okay. Now, this should look similar to what it's going to look like on my paper. Okay. Can I tell what my maximum is now? Can I get it to tell me?
Yeah.
Okay.
Yes.
So now menu, sorry. Analyze graph. Which one do I pick?
Minimum, I mean maximum.
Maximum. And I'm going to highlight it. Right? It'll pop up. So what's my maximum point?
390.
390. Okay. Now if I need to figure out this point over here, what do I do for that point on my y-axis?
Minimum. Oh,
Zero.
The
I
zero.
meant to say zero.
0. Hey.
Okay. So it's at
Track stop.
6, 0. What's another way that I could get more coordinates? So I have more dots to graph.
I'm not sure.
Solving it?
No runner, she's-
Control
The table.
T, get the table, right?
she's no runner, she's no track stop.
So now I have more points. I have a point at 1 and 50, a point at 2 and 80, 390, 480, right? So could I have just pulled up the table to begin with instead of doing the minimum and maximum?
Yeah.
I could have. So on our graph now,
Right.
now we can put all of these coordinates, right? So 0, 0, and then 390,
6.
0, 6. What else were my other coordinates?
150.
Okay, 150. Okay. They should mirror each other, right? Because we have the axis of
150 or
symmetry right
250?
here, which means on both sides it's equal distance from that line.
1 or 250?
Okay, 150, 2 is at 80. Okay.
She's no runner, she's a track stop.
Now I have more points, so it will make my graph more accurate when I draw it. Still not going to be perfect, but having those coordinates there or those points graphed makes it easier for me to have an accurate picture. Now can we answer these questions below?
Yup.
How long does it take for the rocket to reach the highest point?
90.
4 seconds.
Four,
Oh, 3.
No, 3 seconds.
3 seconds. Okay. How high is the rocket after 4 seconds?
80. Yeah. 80 feet.
80 feet. What is the highest point the rocket reaches?
90 feet.
feet. So descending starts at like what? 4 seconds?
No.
No,
So
it's
it,
at 90.
it starts at the 3 feet, or I mean at the 3
3 and a
seconds,
half.
right?
Starts at 3 and a half.
No, it starts once it hits the vertex, it immediately starts coming down. So
Okay,
from
so then it's
3
3
to
seconds.
6 would be how many seconds?
3.
2.
4.
3.
What I tell you?
I said 3.
3 seconds,
Oh,
because
nice.
it's only descending from the time it hits the top until it hits the,
It takes it 6
Ground.
seconds.
Okay.
6
and then,
seconds.
so how many seconds does it take for it to hit the
6.
ground again?
6.
6 total seconds from the time it was launched.
The domain is 0 and 6.
So we've got to write it as inequality,
Right?
0 is
Yeah, that's what I meant.
something.
and the range,
0 to 90, right? Something like that. Yeah.
exactly. There you go. So that's exactly what those inequalities mean, that it includes all of that space from 0 to 6 and 0 to 90. So those last 2 problems are for you to finish, but you do have assignments from earlier this week that you can now work on. You still have about 12 minutes of class left, so you have time to work on that. Your notes from yesterday as well. Like I said, it's easier to just graph it and answer those questions. You don't have to do the math part of it. Yes, y'all can both go. As long as you're not both going in the same one.
Nah, I think I have different marks.
I think you don't.
Okay.
I'm so scared.
Okay. So you have time to get stuff finished now.